Welcome to another Tech AV training program in which you are going to learn about rotary shaft oil seals. During this program, you will learn why these seals are necessary, the basic principles of operation, the most widely used designs and styles of oil seals, and general procedures for oil seal replacement. Let's begin then as we answer the question, why are seals necessary? Any oil or grease lubricated equipment or machinery that has a rotating shaft requires some method of ensuring that the lubricant is kept from leaking out around the shaft area. The device most commonly used is known as a rotary shaft seal. Other common names for the same thing are an oil seal, radial lip seal, or simply a shaft seal. The most widely used name is an oil seal. Oil seals comprise a metal insert which, like a skeleton, provides the frame onto which other components are attached. The actual sealing element is formed by a rubber lip and is part of the rubber molding which encapsulates the metal insert, or alternatively is bonded to the metal insert. Two basic oil seal types are commonly manufactured, namely bonded seals and assembled seals, commonly called metal-cased seals. Note that an assembled seal is not rubber encased. The only rubber component is the sealing element itself, which is normally bonded to the outer case. In operation, the sealing lip contacts the rotating component. Most seals include a garter spring to assist the seal lip in maintaining contact with the shaft. To ensure positive sealing, the lip has to ride on a thin film of oil or grease. This is controlled purely by the mechanical pressure exerted by the sealing element against the rotating component. Should this oil film be broken by a damage mark on the seal lip or on the shaft, then leakage will occur. With no lubrication, the seal lip will overheat. Adequate lubrication is maintained only when you fit good quality seals of the correct type and size. Let's now take a look at some typical and extensively used oil seal designs, beginning with this single lip style. Notice that the lip is not spring-loaded. Such seals are usually used on low-speed, light load applications where grease is the lubricant. This type of seal is often known as a grease seal. Other single-lip seals include a garter spring. The type of seal shown here is known as an A-type seal. Such seals would normally be used in clean environments and on machinery where shaft speeds are reasonably high. The next seal we see is known as a double-lip seal. Notice that only one lip has a garter spring. The lips are opposed, the non-sprung lip being utilized to exclude dust or dirt. Double-lip seals are commonly utilized where dust and dirt is part of the normal working environment. The next seal we look at is called a DUPLEX style, which, as can be seen, contains two opposed spring-loaded lips. DUPLEX, or dual lip seals as they are also known, are required to seal two different fluids, for example, to retain oil but exclude water. In the next example, we see a typical external seal. Such a seal is used where the shaft is stationary and the housing rotates around the shaft, as would be typical on conveyor rollers. Finally, we take a look at what we generally refer to as a hydrodynamic seal. The principal feature is the spiral groove molded onto the lip. The purpose of the groove is to create a pumping effect on surplus oil, thereby pushing the oil back into the mechanism. A point to keep in mind is that an arrow on the casing of hydrodynamic seals indicates the shaft rotation direction. Both clockwise and anti-clockwise seals are available, and they must always match the relevant shaft direction of rotation. Hydrodynamic seals are commonly used on engine crankshafts. After the break, we shall begin to demonstrate correct seal replacement procedures and techniques.